Welcome GeoTrig, this is section 7 for Similarity in right triangles. The essential question is, what are some neat properties of the altitude of the hypotenuse of a right triangle? So let's begin. So this is going to be a little bit hard, so put your thinking caps on while you're doing these notes. Even you. Alright, so we got a theorem here. The altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So here's that word altitude again. So the altitude is a line going from a vertex to the floor of any triangle. So we're talking about specific altitudes from the hypotenuse of the right triangle. So it's dividing it into three triangles. We have the main triangle, and it divides it up into two little babies. This baby over here, and the bigger baby over here. These triangles are all similar to each other. And that's kind of neat. So what are the conditions to make this happen is that you have to have a right triangle, so it can't just be any old triangle. It has to be a right angle, and it has to be the altitude off the hypotenuse. So it has to be this line CD. You can't just go an altitude like that, or it has to be the one off the hypotenuse, and it's making three similar triangles. This has some neat properties, and this is one of those properties that we can play with that using that theorem. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. That's a lot of big words there. So we're cutting it right here, and there's the proportions here, but think of it this way. I like this example. If our hypotenuse is length 4, it cuts if the altitude is length 4 right here, it's cutting this hypotenuse into two pieces. One's going to be a lot smaller, one's going to be like half the size, and one's going to be double the size. And this 4 is actually called the geometric mean. It's not the arithmetic mean where you add them up and divide by how many you got. Geometric. So what is geometric mean? We might have done this a little bit in Algebra 2, but you probably don't remember this. It's the nth root of the product of n numbers. So basically, you take the two numbers, 2 times 8, and then multiply them together, and then just square root it, and that'll get your geometric mean. This has to do with like when you're doing 2 to the first power, 2 squared, and 2 to the third. It's that geometric pattern where it grows exponentially. So you multiply every time, not adding a number every time. So that's what geometric was. But anyways, you take the two chunks of the hypotenuse, multiply them, and square root it. So you get 2 times 8, and the square root of that, which is square root of 16, which is going to be 4, which is what you get for your altitude in that case. 4. Alright, we have this other one related to geometric mean. The altitude of the hypotenuse of the right triangle separates the hypotenuse so that each leg of the triangle is the geometric mean of the length of the hypotenuse. Length of the segment of the hypotenuse adjacent to the leg. So there's a lot of ratios over here, but I like this picture the best. So you have the overall hypotenuse of the big triangle, which is 4. And then you could take any one of the legs, and then it's proportional also to any one of the legs of that hypotenuse, and then you do a legs of that mini triangle. So 4 to the 2 to the 1. You can also go 4 to this one, then to this one. So that's all the geometric mean. This leg is going to be the geometric mean of this overall hypotenuse and this chunk of the hypotenuse. So in this case, 4 times 1, the square root of that, is going to be square root of 4, which is going to be 2, and that's the length of this leg. That's what it's saying there. This is a diagram that kind of says all that together. I don't know how clear that is, and I don't think it is, so we'll probably be doing a lot of this in class. Alright? But let's try some examples. So pause the video. What similarity statement can you write relating to three triangles in the diagram? So we got three triangles. We got triangle, let's call it X, Y, Z. And then we got another baby triangle, and so we want to make this similar, right? So XYZ is going to be, we got this, the bigger of the babies, so that's going to be similar to triangle. I'm putting Y, which is the right angle in the middle, so I got to put W in the middle, and then X is going to be related to Y in this case, because kind of that smaller angle of this big triangle. It's this Y right here, this and this. And then Z is going to be right here. Now this is also going to be similar, so triangle XYZ will also be similar to the little baby triangle. So that'll be triangle, and W will be in the middle again. Angle x of the overall one is going to be similar to x again, and then instead of z, we instead have y. So those similarities. And we also have these two triangles are going to be similar, so I can write it as YWZ is similar to triangle XWY. Alright, try next one. Pause the video. Okay, geometric mean. What you do is you multiply them and then you square root it. So 6 times 15 and the square root of that. So square root of 6 times 15 is going to be 0, carry a 3, so 90, square root of 90. But let's reduce square root of 90. How do you do that? It's not a perfect square. I like doing the step method, so I take out a 2, left with 45, take out a 5, I guess, and left with 9, take out a 3 and a 3. So I can circle the pairs and square the alones, a pair of 3s, and a lone and a lone. So that's going to reduce to a 3 on the outside and a 2 times 5, which is 10 on the inside. That is the geometric mean simplified. Alright, pause the video. Okay, so this is going to get neat here. We got proportions. We got this right triangle and the altitude. So I can write a proportions. Oh, we can do geometric means here. So we've got our altitude y, right? And we've got these two shapes. Well, from that first theorem, it said that the altitude is the geometric mean of the two chunks of the hypotenuse there, that it splits. So we can say y is going to equal 4 square root of 4 times 12. And that's going to be equal to square root of 48, which is going to break up into, let's see, 2, 2, 2, 2, and 3. So pair, and alone, that's going to reduce to 4 square roots of 3. So that's what my y equals. Now my x, well, that's that outside leg. I assume that's that other theorem we did here, where it said that was the geometric mean of the overall hypotenuse and then the leg of one of the babies. So, yes, using technical terms. So x is going to equal the overall, so 16, times the leg of the baby, which is 4. So where does square root of 16 times 4? So that reduces, well, that's like square root of 16 times square root of 4. And that's just going to be 4 times 2, which is going to be 8. So x equals 8. That's it.